Hi students, so we are back today. Today we're going to start with a second part of permutation and combination. I hope you had gone through the first video of permutation and combination. So in first video we had discussed the fundamental difference between permutation and combination. In combination we know this order does not matter, but in permutation order matters. Okay, permutation is arrangement of the objects and combination is the selection of the objects. We know this. And the key word we use in permutation is arrangement and the key word we use in combination is select. The basic formula we use in permutation is NPR, which is factorial n by factorial n minus r. So permutation is arrangement of n different objects taken r at a time. Same, the basic formula we use in combination is NCR. Combination is the selection of n different objects taken r at a time. We discussed the permutation formula when the objects are identical. So if objects are identical, permutation formula that we used it factorial n by factorial r1 into factorial r2 and so on. Now let's discuss few conceptual question in permutation and combination. So we have a question. So we have a word that is strange. Strange, in this word we have 7 letters. And if you see, all 7 letters are different. Let's come to the first part. They are asking that how many 7 letter words can be formed so that S and T occupy extreme position. Students always remember, when we have to fix our extreme position, as in this case we have to fix our extreme position so that S and T occupy the extreme position. Now always remember, we can fix the position, first position and the last position. So if we fix the first and last position, we left with 5 letters, 5 positions, and 5 letters can be arranged by 5 factorial. 5 letters can be arranged by 5 factorial. Now S and T, they also can be arranged by factorial 2 ways. By factorial 2 ways. So the total number of ways or total number of arrangement possible, that is factorial 5 into factorial 2, which is equal to 240. So total number of arrangement that could be possible in which S and T occupy extreme position, they are factorial 5 into factorial 2, which is 240. Now come to the second part of it. In second part, they are asking how many 7 letter words can be formed so that STR occur together. Always remember, whenever in question they ask you a group of word comes together or a group of letters, they always occur together. Always assume the group of letters or group of words as a single letter. So over here str should come together, so we can assume str as a single letter. So if we assume str as a single letter, the letter we left with, basically there will be 5 letters. str 1 letter and a and g 4 letters are there. So total there will be the 5 letters, and 5 letters can be arranged by factorial 5 ways. But students, this str also can be arranged, and they can be arranged by factorial 3 ways. So the number of possible arrangement will be factorial 5 into factorial 3, which is equivalent of 720 ways. Come to the question part of question number 3. In question number 3, they are asking how many 7-letter words can be formed so that vowels are together. Now they are asking that vowels are together. If you see in the given word, the vowel letters are A and E. A and E, these two letters are the vowel letters. So indirectly they are asking that A and E should come together. Again, what concept we can apply? We can assume A and E as a single letter. So if we assume A and E as a single letter, we left with 6 letters. And we know 6 letters can be arranged by factorial 6 ways. Students, but A and E also can be arranged, and they can be arranged by factorial 2 ways. So the total number of possible ways, which will be factorial 6 into factorial 2, that is equal of 1440 ways. Come to the question number 4. In question number 4, they are asking how many 7-letter words can be formed so that vowels are not together. Now, in the previous question, we solved that the number of words can be formed so that vowels are together. Now, in question number 4 or part number 4, we have to find out that vowels are not together. How can we find out? Yes, we can take the difference of total number of words and the words in which vowels are always together. So total number of words, how many total number of words can be possible? So we have total 7 letters, and 7 letters can be arranged by factorial 7 ways. So factorial 7 words can be possible. Now the words in which vowels are always together, they will be your factorial 6 into factorial 2. We already solved it, we just solved it in previous question. So factorial 6 into factorial 2. So the number of words in which vowels are not together, they will be factorial 7 minus factorial 6 into factorial 2, which is equivalent of 3600 ways. Now come to the next question, students. Now come to the next question. Next we have a circular permutation. We have circular permutation, students. What is circular permutation? Circular permutation is basically, suppose you have to place some people around a table, or either you need to find out the number of possible ways for the circular things. Then we use this circular permutation concept. Always remember, in circular permutation we have two cases. First case, if clockwise and anti-clockwise order are different. If clockwise and anti-clockwise order are different, then the number of circular permutation is factorial n minus 1. So the number of possible ways, that will be your factorial n minus 1. For an example, if n persons are to be arranged around a circular table or round table, then the number of possible ways will be your factorial n minus 1. Now case number 2 is if clockwise and anti-clockwise order are different, then the circular permutation is given by factorial n minus 1 by 2. Again, let's take an example. Uh, Number of arrangement of n beads to form a necklace or circular wire, that will be your factorial n minus 1 by 2. One example is given: in how many ways a wedding garland can be formed out of 15 flowers of different colors. So in this case, your clockwise and anti-clockwise order does not matter. So we can use the second formula. So the number of ways, that will be your 15 minus 1 factorial by 2, which is factorial 14 by 2. Now let's come to the third example. Let's come to the next example. Next we have a box contains 2 white, 3 black and 4 red balls. How many ways can 3 balls be drawn if at least one black ball is to be included in the draw? Now this is basically the problem on combination. How can you say how many ways can 3 balls be drawn? Or I can say by how many ways can 3 balls be chosen or 3 balls can be select. So which keyword I am using? I am using the select keyword. If I am using the select keyword, the problem will be your combination problem. So if you see in back, there are 2 white balls, 3 black ball and 4 red balls. Now, so total 9 balls are there. Among them 3 black and 6 are non-black balls. 3 balls, if I take randomly, if there will be no condition given, then I can say 3 balls can be chosen by 9C3 ways. Total 9 balls I have to select 3 balls. By how many ways I can select it? By 9C3 ways. So total 84 ways I can select 3 balls. But there is a condition, and the condition is at least one black ball is to be included. It means at least one black should be there. So there will be 3 cases. The case number 1, one black ball and 2 non-black balls can be select, or 2 black ball, 1 non-black ball can be select, or we can select all 3 black balls. So case number 1, if 1 black and 2 non-black balls can be select, then how many ways, by how many ways we can select it? 1 black ball out of 3 black ball. By how many ways? 3C1. And non-black balls are how many? Non-black balls are 6. I have to select 2 balls from non-black balls. By how many ways I can select it? By 6C2. So total 45 ways. Case number 2, if 2 black balls are there and 1 non-black balls are there, so 2 black balls I have to select out of 3 black balls. By how many ways I can select it? By 3C2 ways. And 1 non-black ball I have to select out of 6 non-black ball. By how many ways I can select it? By 6C1 ways. So total 18 ways I can select it. Now come to the case number 3. In case number 3, we can select all 3 black balls. If I select all 3 black balls, there will be only a single case. So the total number of cases in which 3 balls can be drawn such that at least one black ball should be there, that will be your 45 plus 18 plus 1, total 64 ways. Now come to the next question, students. And next we have out of 7 constant and 4 vowels, how many words of 3 constant out of 7 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can be formed? So again it's a permutation and combination mix-up problem. See, out of 7 constant words, I have to select 3 consonants. So, by how many ways I can select it? By 7C3 ways. And I need to select 2 vowels out of 4 vowels. By how many ways I can select it? I can select it by 4C2 ways. So, I can select 3 consonants and 2 vowels by 7C3 into 4C2 ways, total 210 ways. But I need to form the words. By how many ways I can form the words? Yes, there will be total 5 letters and all 5 letters can be arranged. All 5 letters can be arranged by how many ways? By factorial 5 ways, which is equivalent of 120. So the required number of ways will be your 210 into 120, which is 25,200 ways.